Hello class, this is a video tutorial on three-dimensional trigonometry. Now, as you've seen in the previous two videos, it doesn't have anything new in terms of mathematical concepts, except it's just a challenging application of trig concepts in a 3D perspective. So, let's get straight to an example here. Frances stops to admire a tower that is due north of her. Let's stop there and actually draw that. So, something that's due north, let's call this point A for Frances's first position. And due north of her is a tower. So there is the tower. And note that the angle of elevation to the top of the tower is 10 degrees. Now what we have here is a top view. In order to draw an angle of elevation, that is a side view. So let's draw this in a side angle. So here's point A. Here is some tower. And north is that way. That is north. From where Frances is to the top of the tower is 10 degrees. So here's the top of the tower. And here's the base of the tower. B for base. Alright, let's keep going. She walks for 3 kilometers until the same tower is directly west from her. So let's draw that. For the tower to be west of her, that means she would have been somewhere here. Could have been anywhere along here. Because from here, the tower is directly to the west of her. So she walked from point A to point, let's call that point C. I can't use B, by the way, because I've already used it here. Let's call that point C. And that would be 3 kilometers. That's the top view. In the side view, she would have walked somewhere along here until she's directly to the west. Until she's directly east of us. That's point C. And that's 3 kilometers. And now she notes that the angle of elevation is now 12 degrees. So from the top of the tower to where she is now, that angle is 12 degrees. So I hope you can see that this is a top view. And this here is a side view. Now, from these two diagrams, we should be able to calculate what the questions will now be asking of us. So here we go. Calculate the height of the tower. Let's label this as the height. Let's label it in purple. Oh, actually, let's go over the top of it. That's the height of the tower, H. Now, for simplicity's sake, you'll see in a moment, I'm going to start labeling the angles, the sides that we need. So I'm going to be needing, let's do this in orange, side AB, let's call that X. And we also will be needing side, let's do it in a different color, let's do this in this green here, side BC, let's label that Y. So here we go, let's calculate the height of the tower. From this point, if we're unsure exactly what to do, what we do actually is just make any expression that we can for H. Okay, so let's do it for this angle. Tan 10 degrees is equal to opposite over hypotenuse. Opposite H, sorry, not opposite over hypotenuse, opposite over adjacent, and the adjacent X. So H over X. And from here we can say that X times tan 10 is equal to H. Let's do the same for this angle here. We can do it for tan of 12. Tan of 12 degrees is H over Y. And from here we can say that Y is equal to, Y tan 12 is equal to h. So we have two expressions for h. Now, it may not seem very clear as to what we can do from here. Now, it seems as if we need to figure out what x and y are. So let's figure out if we can have any expression for x and y. Let's label this a little bit further. X is the same length here, and y is this same length here. And I hope you can see that we have a right angle triangle here using xy in the hypotenuse. Let's see if we can't use that somehow. Here we go. This will be x squared plus y squared equals 3 squared. And now from here, we can kind of see that we could utilize x and y. So if we can figure out x and y and substitute it there, maybe we can figure a step closer. So let's make this x the subject, so it would be x equals h over tan 10 degrees. And this will be y equals h over tan 12 degrees. And now from here, we can substitute it. X, we can substitute here. And y, we can substitute here. Let's do that. This will be h on tan 10 squared plus h on tan 12 squared equals 9. Expanding this, we get h squared on tan of 10 squared plus h squared over tan 12 squared equals 9. Now it's seemingly more difficult, but just using our algebraic techniques, we can factor out h squared. So it'll be h squared outside of, actually no, we're going to use some trig identities here. If we factor out the h outside, we're left with 1 on tan 10 squared. We can simplify this as that's going to be cot of 10 squared. And similarly, this one we can simplify as well as cot of 12 squared equals 9. And from here we're going to be dividing by this expression in the square brackets. So we're dividing everything by cot 10 squared plus cot 12 squared. This will give us the expression. I'm just going to make some more space for myself here. This will give us h squared, because we've now divided this out. This will be h squared equals 9 on cot 10 squared plus cot 12 squared. Then we take the square root of everything. H is equal to the square root of everything here. Now this is what we need to type in to our calculators. Here we go. This is going to be 9 on cot of 10 squared is 1 on tan 10 squared plus cot of 12 squared is 1 on tan 12 squared. Whoops. 9 divided by everything it should be. Let's get rid of that. 9 over everything. There we go. So that's going to be let's write this out in more steps. H squared is 0.16575. Okay, now we're going to take the square root of that. So square roots of everything. This will give us 0. So H is equal to 0.407, which is approximately 407 meters. So that is the height of the tower. Next question is calculate the bearing that Francis is walking. So the bearing, actually, you know what, just so that we're not scrolling up and down, I'm going to copy this out. There we are. The bearing that Francis is walking. So in this question, we're now going to be looking for that angle there. In order to find that angle, well, we're going to have to do some, some inverse trig. And for this, I'm going to make it nice and simple. I'm going to use cosine of theta equals adjacent over hypotenuse, so x over 3, which means theta equals cosine of inverse x over 3. Now it's just a matter of figuring out what the length of x is. Well, we already know what h is. H we found to be 407 meters. So we're going to use this answer to figure out what x is. So here we go. Using this triangle here, we have tan 10 degrees is equal to 407 over x, which if we use some trig, we get x equals 407 on tan of 10. Writing this in, 407 divided by tan of 10 degrees, that is 2,308 meters, 2308 meters, which is approximately 2.31 kilometers. So that is x. Now, well, we have the value for x now. X is 2.31 kilometers, which if we now type in, we can get this to be cosine of inverse 2.31 over 3. That's equal to 39.64, which is about 40 degrees. So I hope that gave you an insight into further applications of trigonometry in a 3D perspective. Hope to see you in the next video. Best of luck.